Hello and welcome. You're listening to episode number 46 of the podcast At the Crossroads of the Safe Network, right here at safecrossroads.net. I'm your host, John Ferguson, the simpleton of Project Safe. Hey, not everybody can be a geek. I'm certainly not. Most of us aren't. But I like to talk. And I like to find out. I like to get a high-level understanding of things, even if I can't get right down to the metal. Well, first of all, I would like to give a shout-out to MaidSafe. MaidSafe, the company that's been bringing along the Safe Network for so long. They've sponsored this show, and that really helps. MaidSafe's an incredible company with open source in its DNA and kindness and persistence at its heart. Really an incredible group of people. Anyway, what is the Safe Network? The Safe Network is, well, SAFE stands for Secure Access for Everyone, with privacy, security, and freedom built in from the ground up. And that's a mouthful, but it's a very intricate project. You know, how do you really secure data and communications in a way that does away with central intermediaries? How do you have a completely serverless peer-to-peer network? Well, MaidSafe has found a way to do that and has been working for quite some years to lay out all of the necessary components to actually bring that into being. Thought it would be released earlier. It's not. But the progress is substantial. Yeah, very exciting, actually. I think we're going to see some, I'm not making any time predictions, but the journey is the thing. There's some really neat stuff, and we're going to talk about that here shortly. Before we do, I would like to, let's see, there was an article that MaidSafe put out on medium.com this last week or so called Why the Internet Needs Evolution. Again, you can just look up MaidSafe or enter that title, you'll find it. If you check out MaidSafe's channel there's other things as well. A lot of good stuff. That's a great article. It kind of sets the stage as to where not just MaidSafe, but the whole Internet is having to go. The Safe Network is just one solution working in that direction. Another thing I want to highlight is an RFC, request for comment, on the GitHub, under MaidSafe. It's about the public name, about a proposal for a public name system. Now that, when you're talking about peer-to-peer, that gets very interesting. How do you handle that without a registrar for public domains and a domain name resolution when you say, well, you type in a domain, and this is all real unique in a completely autonomous peer-to-peer network. And this is a proposal on how to do that. You might find it interesting. Now, last episode, we talked with Nikita from MaidSafe about the routing layer, the routing library called Crust. Crust stands for Connected Rust. It's written in the Rust programming language, and it is a library for automating peer-to-peer connections across a very broad network where connections might be difficult. This needs to be very responsive. Now, MaidSafe would have happily used an existing library if such were available, but none suited the needs. So they're having to build this, and it's quite something. But at the same time, it's open source, so others will be able to use it too. Anyway, we go into detail about the Crust library and the public test, the first public testing of that and the results thereof. Great episode number 45. I recommend it. I had planned this episode just to contain a brief follow-up and a little bit of a short interview. Say, hey, how'd it go? What happened on test 2 and so forth. But I got Spandan, who has been around MaidSafe for a long time and has his fingerprints all over different parts of the network. So not only did we examine the results of the second test and got a much deeper understanding of the Crust library and how it functions and so forth, but we started really looking into the higher level of, well, why does it need to be that way? Why does it need, and what are the demands of the routing library, which lays above that and is actually the heart and soul of what makes the Safe Network unique. And by no means did we do anything close to comprehensive. But we kind of got a peek through the door, just got to see a little bit more leg, and makes us interested in what's going on. We're going to be breaking this down in the future quite a bit more extensively, but we had a really good talk. I think you will enjoy it. It's a little more technical. I didn't stop and demand, definitions of everything. I did on a few that I felt were vital. That is kind of part of my simpleton job, going, what? Please define that. But so there were a number of things that if you don't really understand what we're talking about, you might want to go back and listen to the episode number 45 first, and then a lot of it is a lot more sensible. We can't cover all the ground every time. So here we go, without further ado. With us now to explore the recent Crust test and, hey, maybe some other things about the Crust layer and how it works, we have Spandan Shamar. He is a member of the Crust team at MaidSafe. Spandan, welcome.
Thank you.
Yeah, touch about yourself. Anything pertinent? Not your whole life story, but what's your background and how long have you been with the team?
That is my whole life story. I've been working with MaidSafe from late 2014, and then saw the transition from C++ to Rust and all that stuff. So I have my fingerprints on almost all the MaidSafe libraries, from Safe Client Libs to routing to Crust and all the satellite libraries as well that MaidSafe owns. Currently, I'm the backend system manager, so I overlook the Crust tests and everything that's happening in Crust library as well. I do coding because nobody in MaidSafe gets away from coding. Even the CTO sometimes has to code. So that's the life in MaidSafe.
Well, cool. Well, you're a very valuable resource. So let's pile in here. So the last episode we had an interview with Nikita about Crust and the Crust tests, and the first one had been done, but I thought an update would be really good since the second one was done. So first of all, let's talk about the process of evolving the repeated tests. What's the target for testing? Do you see what I'm saying? It's like, okay, we've had one test, and what's the overall evolution of testing, and where are we in that evolution, I guess?
Right. So the first one, before that one, we never actually had an idea how Crust would fare with the community-wide testing. So that was just a shot in the dark kind of a thing, that we have something. We have tested it internally, but throwing it out over there into the wild, don't really know what's going to happen, so let's do it. And we did that, and we didn't get bad results at all. We didn't get like exceptionally impressive results, but we never got bad results. So that was good. We saw the trend. It always used to. So all these Crust tests, what they want to establish is what is the connectivity percentage that it is going to get you, right? Because Crust, being the bottommost layer in the MaidSafe project, is an IP layer. And as we know, that internet is IP. So we'll require an IP layer somewhere. So to connect more and more peers, which is of prime importance in any decentralized internet, because you don't have a server to correspond to. So it's very important that peers behind NATs and firewalls can talk to each other, preferably directly, so that there is no intermediary or a relay. And that is what this Crust test was trying to see, how good it is in forging those connections through the routers of the users. So the first one was okay. We got the results, we analyzed some of them, and then we proceeded on for the second one. Of course, with those analyses, we wanted to tweak some parameters, especially the config file that goes out with Crust. It has been made into a config file so that it's easy to tweak things instead of hard coding.
I'm sorry, it's what kind of file? I'm not hearing.
It's a config file. So a config file, configuration file that goes out. Configuration
file. All right, good. Yeah, just as a caution, there's an awful lot of people that are very non-technical like myself that we're trying to communicate with. So we in the last episode we covered NAT traversal and so forth. So anybody who doesn't know what all that's about, I recommend that episode with Nikita. as a groundwork. So we don't want to get we don't want to tear all that apart again. But but for any other things, we want to make it as high level as reachable as possible, while really still talking about the results and where we're going. So sorry to interrupt. Carry on. So now, what about config files?
Yeah, so they contain the parameters that we can tweak, right? So to make it easy and not put it into the code itself, which will make it insanely difficult, you need to recompile the code every time you change the parameters. So we put it into a config file, especially the important ones, and we wanted to tweak them and test and relaunch the test and see how they improve because of findings of the previous test. And one more significant stuff that went into this one, the latest one, is the last one did not really have any direct connection, so we went only with NAT traversal. And this one, we wanted also to count on how many direct connections we can forge.
So direct connection, as opposed, in other words, that's not having to go through a router. That's directly IP to IP without any interposing firewall or router to go through. Is that what you mean?
Right. So internally, we classify these as like direct and hole punched connections, though that is not like a very technical accurate, because all connections are eventually direct, right? Unless you are going through a relay. So what we classify as direct connection is something for which we did not have to hole punch through a router. So
I got it.
There are a couple of techniques of doing it. If you are a public facing IP, then you are directly connectable anyway. So, for instance, when you type something into Google, it goes to the servers, Google servers. They're all public-facing IP, so there's a DNS resolution, and that gives you the IP, and it goes over there when you type google.com, for instance.
Right.
So in those cases, you are directly connectable, right? Now, peers behind NAT or behind routers can also be directly connectable because you can port forward, and then once you port forward, you're publicly available on that port. So this test was trying to traverse NAT using those kind of techniques. One of those techniques is something called UPnP, Universal Plug and Play. So if routers support UPnP, then what we can do is, instead of the person manually going to the router and forwarding a port and doing all that stuff, we can, through code, talk to the router and say like, hey, can you forward this port for me? And if router says yes, then basically you have a port that is publicly available. Now, there are a couple of things with this, right? So first of all, your router has to support UPnP. Once it supports UPnP, you use a protocol called IGD, Internet Gateway Device. That's a protocol Crust uses to tell the router, can you please forward this port for me? And router can either say no, or it can say yes. So this test was mainly to find out how many people over there have routers who have this UPnP thingy enabled by default, because if it is disabled, you cannot talk to the router, right? So you'll tell forward this port and the router will say no. So how many people by default have these things available, and how many can we, out of those who have this thing available, can we just go to the router and say, hey, forward this port, and can the router do it? So once you know that, we roughly know what percentage of people out there we can be sure we can directly connect to. So it'll give us a ballpark figure. So the second test was more geared to find that out. And also we improved our NAT traversal, like our hole punching, a bit by tweaking the parameters, which eventually helped us hole punch through China as well.
Oh, wow. Oh, yeah. So that's very interesting to folks. It's legendary that, the Great Firewall and China's control over things. I don't know, maybe too soon to jump to that, but since you mentioned it, how are we doing in relationship to onboarding those connections without difficulty?
Yeah, it looks good so far, especially with UPnP and IGD. If you combine the results, we have over 80% success from China to other places in the world. I don't have the stats ready, but I think it's around about that one, right?
Well, that's fine. Yeah, I just wanted a ballpark, of course. These things will change.
Right. And with hole punching, what we had seen in the first test release was we achieved close to zero with hole punching because there are tons of technicalities involved in this, right? So without going into the technicalities, it's difficult to explain what changed and what improved. But in the second test, we tweaked a parameter and we thought, let's use this because we try several things while hole punching. And those are all part of the configuration file that we give out. So one of the configs we tweaked, and that sort of brought some amount of success, let's say, to and from connection from China. Yeah.
Cool. So, let's talk about the specific results on this test and how they stack up with expectations. What were you expecting to accomplish with this test, and how did that fare?
The main thing we were seeing is, unless you have a configured firewall, like you can configure your firewall to do anything, right? You can configure your firewall to literally make this test return 0 success. You can just say, like, I block all incoming connections, for instance. It doesn't matter whether it's hole punched or not. And there are people we found in the community, there are people who tinker with the firewalls and do that. That's why it's necessary for as many people to participate as possible, so that we don't skew the results, or someone cannot skew the results, right, using a wrong configuration or something like that. The trend always has been that it starts off really great. Like, it starts off as almost 100% connectivity, and then as time progresses, you see a gradual decline because more and more people participate. They tinker with their firewalls, they do things, and that either boosts the connectivity or that brings it down. On an average, it has been quite good. It is actually better than what we had expected, because we thought like we had to work quite a bit to get to where we already got to. So when we saw the results, it was great. And 75% connectivity out of, 11 or 12,000 connections is pretty good. So so what we set out to do in this test, I think we have a pretty good idea of where Crust is right now and what we need from it. And that also ties into the requirements of routing from Alpha 3, which is the next interesting part.
Okay. Boy, that leaves a couple branching questions. Let's see how to approach this. So what are we looking at next? What is the next test going to be targeted at?
Yeah, so something very interesting came up after that. So we had this internal analysis of the results. And what we did find was we weren't expecting a lot of UPnP successes, right? So we thought like the majority of the routers out there are going to have UPnP disabled, and we are going to fare miserably in the direct connection part. Direct connection meaning that you don't hole punch. It's like an analogy that we use. But the results were quite different, kind of pleasantly surprising that we could forge a lot of direct connections. And what that meant was now the layer on top of Crust is routing, right? And routing sort of dictates Crust, how it should perform, or what is needed from it, because after all, routing is MaidSafe, right?
Right. Yeah. Well, that's something that I want to actually, we may dive into a little more detail on that a little later. Let's focus on Crust, though. Yeah.
Right. So looking at it from the routing point of view, one of the invariants of routing right now is it needs everyone to be connected. So that's the invariant it is having right from Alpha 2. So unless we improve that invariant, or if we can ever improve that invariant, what we know right now is we need 100% connectivity. And hole punching cannot get you 100%. So that's not even practically possible. I don't even think that's theoretically possible, considering the kind of routers and kind of behaviors you have for hole punching. So what we went with is the overall success percentage is around about 75-80, which is pretty good. This is involving everything: hole punching, TCP hole punching, UDP hole punching, TCP directs, and all that stuff. And just having TCP directs and TCP hole punching gets us to, say, like 65, 66-ish percentage. So the UDP hole punching adds an extra 10% and all that stuff. But it won't take us to 100%, right? And currently routing invariant wants us to be at 100%. So what we do in those cases where we cannot connect is we look for relays, we look for tunnel nodes. And that code is already there in routing. It looks for tunnel nodes.
We look for a tunnel.
Yes, we look for tunnels. And so say like I'm connected to you.
Yeah, describe that for us.
Exactly. So say I'm connected to you and I couldn't connect to Doug, but you were connected to Doug, right? I tried connecting to Doug and Doug tried connecting to me. We failed. But routing requires that if I'm part of a section, I should be connected to Doug if he's a part of the section as well. Or even if he's a neighboring section, right? So
right.
It ties into disjoint groups and others. So what I will do to satisfy that invariant is I'll ask you, hey, can you tunnel me to Doug through you? And you go, yeah, okay. And
well, basically to be a proxy for that connection.
Exactly.
Yeah,
exactly.
okay.
That makes the code very complicated because obviously you need to deal with malice and all that stuff. So you could be a malicious node and you could not ferry my information to Doug, and then I need to find out whether it was Doug who did not respond or whether you who did something and all that stuff. So there are solutions, of course, but the thing is it involves more boilerplate. It makes it more complicated. So we try to avoid tunnels as much as possible, which is why it is good for Crust to get as much connectivity as possible. And now from the results that we see, we already achieve a pretty good connectivity just using TCP directs without even hole punching. So for Alpha 3, instead of putting more, we are going to improve the hole punching thing in the background as well. But what we were thinking is we are going to be miserable over there, and we will need to do a lot of stuff to improve that stuff. But the tests showed that we don't really need to do much over there. Even if we try very hard, maybe we'll bolster this entire percentage by a 3, 4, 5, which isn't much, right? Because once you hit kind of a threshold,
it gets harder as you go. It gets harder as you approach the limit.
Exactly.
Yeah,
exactly. So the idea that we have currently floating is this: that let's go with TCP directs because it's already giving us quite a good percentage. Let's go with the UPnP and the IGDs. That is also part of net traversal. And Crust is going to tell routing that I have successfully established a connection if the direct connections succeed. What we will also require, or it's just an idea right now, what we'll also require is if there is any joining node, that joining node will be allowed to join the safe network if the safe network can also connect to it. So previously what used to happen is if you are a joining node and you say like, hey, can I be connected to you guys, or do you want to accept me? We say, okay, yeah, connect to us. And either we connect to you or you connect to us, or we accept you, right? But now what we are going to enforce as a group consensus, like the entire group is going to enforce this, is if the group can connect to you, the majority of the group can connect to you, only then you will be inducted into the group. So what that means is if I can connect to you, then you have either UPnP available or you are public facing or something. So it gives us a very good chance that other people will also be able to connect to you and you will be able to connect to other people. So that sort of increases the connectivity that routing requires, reducing the number of tunnels. In the meantime, we'll also do that hole punching and net traversal thingy in the background. But that is just for stats collection because eventually, Alpha 3 is the nearer one, right? Eventually, when we release Beta and other things, we will require the entire, we need to go the whole hog or something like that, right?
So let me run this back just to get to see if I'm understanding correctly. So basically, you're going to connect with everybody that's possible. Mm-hmm. But Crust also goes, well, yeah, but if we can't, you can't join the group unless you have a certain certainty of connectivity.
Exactly, right? Exactly. So if there's a group of 8, say the majority is 5, and if 5 people can connect to you at least, then you are inducted into the group because those 5 people are going to vote you online and all that stuff. And then that'll accumulate and the entire section is going to take you in. But if previously, if you could just connect to any 5 or more than 5, it's even better, you would be taken online, right? But now we are enforcing a bi-directional one. So you should be able to connect to us, but we should also be able to connect to you. Only then we vote you online. So that way we weed out the people who sort of have poor connectivity and so on and so forth, who are not eventually going to help the network. So that is basically Alpha 3.
Cool. So I think I get a pretty good idea of what Crust is trying to do. So what's the next test, I guess? I guess that was the question.
Currently, I don't think we'll have more tests unless we see something in the code and go like, if it did that, then this would have certainly improved, like, I don't know, 12% or something like that. I don't know. So
Crust is looking pretty good overall.
It is looking pretty good. So we just have to tie in a few pieces together, but that is all the implementation details. The output from the tests was okay.
Sure. Well, and I'm sure over time different needs will come up and adjustments will have to be made. Mm-hmm. But that leads us to, I think we've kind of covered the results of the test, and that's really cool. Mm-hmm. But I hadn't planned to go here when I was going to make this a really short interview before, but this is an opportunity to kind of go to a different level? Because all of these different aspects are interactive. You have the Crust library and you have the routing library, but these are highly interactive.
Oh, yes.
Because the connectivity is there to do something, and routing is what does everything, right? Is that a fair representation? So could you give us a nutshell? And I want to have further podcasts where we really get down into detail and break this down and look at different aspects. But could you give us an encapsulated view of the routing layer? Well, you mentioned in passing that is the safe network. Why do you say that? And what all does the routing layer do?
So routing is the, what do you call, the brain of MaidSafe, right? So it controls literally, because that is the network. Crust is...
I'm sorry to interrupt, but it just hit me. Like, Crust is a connection layer that any peer-to-peer, any appropriate one that it fits can use, and they use it to make connections for their network.
Exactly.
But so routing is, this is the network. I got what you're talking about now.
Right, because Crust cannot determine what malice is there, or if you twiddle the bits, what it is supposed to do. At the most, it is going to sever the connection, right? But it won't sort of penalize you or de-incentivize you from doing something bad. So it just happens to be that today's internet is on IP. If it was on ATM or something else, then we would have a different layer instead of Crust.
If it was on what?
ATM, it was kind of a competitor to IT.
Oh, you said it now. Tell me, because I don't even know what you're talking about.
ATM, I think this is a long time back, right? I wasn't even born then. So there were two competing ones. So one was like ATM, I guess, asynchronous transfer module or mode, I forget which one. And the other one was this Internet Protocol. So Internet Protocol is the one that we see today because it took over. Some people still believe that ATM would have been a more superior one, superior form of that base layer protocol.
It's kind of like Betamax probably should have won the video wars, but it didn't. So we're stuck with VHS. Yeah. Okay, I got it. All right. Well, that's enough said on that. Thank you. I don't want to go into too much detail on that. Okay, go ahead.
So the lower layer does just that, right? The MaidSafe layer, on the other hand, doesn't really care whether the bottom layer is IP or ATM or whatever it is. It just happens to be that it is IP in our world. It creates its own layer on top of that, which is that ZOR address space, the famous ZOR overlay
XOR,
network.
Exclusive OR. Well, that's a whole other thing. Yeah, exactly. I will link in the show notes an episode of the Safe Network School where I detail XOR. As well as I could figure out, but it seemed to have been acceptable in terms of the address space and so forth. Mm-hmm. So that's basically, in a nutshell. Could you tell us what that means in terms of the layout or of the network? I think we can't just run past XOR.
Yeah, so just imagine, like, I can give you an example. This is a very simplified version of it, right? So.
That's
perfect. If it was so simple, like MaidSafe would have been done by now.
Right.
So the thing is, like, just imagine that address is a 32-byte value. So 32 bytes is basically 256 bits if you multiply by 8. So it's a big address space. So that is an address, right? So every node that comes up in this network gets assigned a 32-byte name. You can call it its unique identity or identifier. It happens to be that the identifier is exactly the same as its public key, public signing key. So you can tell it, like, okay, so you claim this address is yours or this ID is yours. Can you sign something and prove it to me? So it can also sign it using exactly the same public key, because public key is the name of the node. So once you have these nodes coming up, you have more and more people joining a section and forming this wonderful section, but at some point you need to split, right? Otherwise we go into the blockchain territory where everybody knows everything and all data is contained with everybody and it's not scalable. So the ZOR address space sort of starts dividing itself. It's just like cells mutating, or not mutating, what's it called? Dividing themselves.
Dividing, yeah.
Yeah. So once you reach a critical mass, it says like, okay, let me split into two, and then split into further. So you form like a binary tree of sections.
Okay. Yeah, and that applies to the entire monstrously large address space
exactly, and then
of the
you have
network.
then you have the problems like once you split enough, people are not going to know each other, right? When you started at the Genesis, obviously you knew everybody, and then you split into two. Those two groups knew each other. They split into four, two further, so in total you have four. Now things start to get interesting because the invariant that we have, like the Cadenlia invariant, is you need to connect to only those who differ to you in one bit position in the prefix, blah, blah, blah. So there's some maths, right? What that eventually means is like you are not connected to all the groups now, or all the sections now. And more you split, there are more number of sections that you are not connected to. So if somebody sends you a message from that section to you, how do you verify whether that section is a genuine section in the network, whether things are... So how do you catch malice? How do you penalize things? And all this stuff. So those form the complicated areas of routing.
Wow, that's really interesting. The visual picture of that is not dissimilar to groups in humanity.
Yeah, exactly. So say,
your friends and family is one thing, but when it starts stretching out too far, you go, how do I know what those people are doing on the other side of the address space? I don't know. I got a message here, but how do I know that's real? How do I know what that? Maybe it was the Russians,
guys,
you know.
Yeah. How do you trust those guys?
And for my Russian participants, that's a joke, especially in the United States right now. Anyway, sorry to interrupt the flow with that realization, but so if you can pick up the thread, carry on.
No, absolutely. So that is what basically routing is, right? And the name itself, the routing, it does what it says on the tin. So if you send something to it, and if you say that, probably it's better if I take a client-side example because people are more used to that. So if you have data as a client and you want to publish it to the safe network or store it in the safe network, so you have a file, an MP3 file, and you say, like, I want to store this file. So that will go to the routing layer. Routing will figure out where that needs to go. And where that needs to go is everything that goes into the safe network is sort of has a header, like just like you have a TCP header or an IP header, a safe network thingy has a data has a header. That header also happens to be a 32-byte number. And routing is going to figure out like which address space is closest to this 32-byte number and go to that address space and tell the vaults over there that please store this data for me. And the vaults are then going to store the data. So whether you choose 8 closest vaults to replicate the data or 20 closest vaults, those are up for debate. But that is the overall idea, right? So you go to some address space and then you replicate the data in that address space among some of the vaults. So that is what routing does. It makes sure things are secure, and it makes sure that there is no malice, and it makes sure that everything is trusted and, of course, anonymized.
Wow. So that has so many different moving parts. Is there anything more we should talk about on routing, just as a high-level thing? Because we've touched on many things there that I think we're going to have to peel apart much more deeply, but I don't want to miss anything from a high level. Mainly, since we're talking about Crust, we're talking about the routing layer. What it is what are some of the interactive necessities? What does Crust need from routing, and what does routing need from Crust in order for the network, which is basically the routing layer, to properly function? Is there anything we should touch on there?
Crust, so we try as much as possible not to couple our libraries too much. So the ones that are at the bottom of the stack, like Crust, don't really have any expectation on the routing layer. Routing, however, since it is a consumer of Crust, will want Crust to do certain things. So routing is going to have some expectation, maybe. Crust, probably the only expectation that it has is like, you tell me to do something, I'll do something for you. Just like a normal library, right? So library does not know who the user is going to be eventually. So it'll do most of the things and say that these are the APIs and the interfaces. You call it and I'll do the thing and I'll return you the result or something like that. Similarly, like safe client libs have certain expectation on routing. Routing does not really have any expectation on safe client libs because it is safe client libs is the consumer of routing, right?
Safe client libs, safe client library.
The safe client library. So in the
that's the library that actually handles the client, not the structure of the network itself, but the interaction with users, right?
Exactly. So that's helping the users use the safe network, right?
Right. Okay. I just wanted to make sure our nomenclature was defined here. Mm-hmm. Okay. I'm sorry. I hang up on those things. Could you pick up the stream again?
No worries. Yeah, that's basically like the overall idea, or at least what we strive to do is not couple the libraries too much. Libraries should see itself as this is my responsibility and I need to do this. How people use me is up to them. Like give them the tools to permute and let them do the permutations, right? In various ways they can use you. Routing, what we've realized over some years is that if we have an ordered consensus, things would be much simplified in routing. If you don't have an ordered consensus, if you have just a naive consensus, which is unordered, will it be impossible to create a network, a safe network? Not at all. Probably there are ways. But if there is an ordered consensus, it simplifies a lot of things because the permutations involved are a lot less. It's easier to wrap your head around it and all that stuff. And for that reason, we needed a library or some kind of a mechanism or an algorithm to give us an ordered consensus. And that then we go to the parsec territory, right? The thing, the white paper and all those algorithms that work going on.
Right.
Inside.
Yeah. Well, we've got some earlier episodes on parsec, and I'm sure we'll be covering it more. So the parsec really exists at the routing layer, right?
Yes. So routing is going to be the consumer of parsec.
Okay.
And that's about it.
Well, that opens a lot of doors, and I think we'll probably leave those doors to be open at a later date. Because when we get into the I wanted to touch on that, but that's definitely something we're going to be piling into in the near future. But you've helped us, peek through that door a little bit anyway, and I appreciate it. So the Crust test was successful. You've got a pretty stable platform to move forward with. Is that a pretty good conclusion on where we stand right now?
Absolutely, yes. It's been more impressive than we thought because devs are the, what do you call, they sort of, they're the most pessimistic lot, right? Because devs are never satisfied with their work. They'll always be, because of that 0.001%, it's a horrible library kind of stuff, right? But the world will just go like that. It works for me 99.999% of the time.
That's that's unacceptable. Yeah. Yeah. Well, that's good.
Yeah. So from the devs perspective,
that's a good initial response. Then you have to level practicality and actual, not let the perfect be the enemy of the good.
Right. Yeah. Yeah. So from the devs perspective, I'm always like, yeah, it's done good. But if I just throw my devs hat away or something like that, I might tell you that it did more than good or something like that. So far it has been more impressive than what we thought it would be.
Well, good. That was the main thing we wanted to talk about today. So, Spandan, I look forward to talking to you more in the future. I'm surprised we hadn't connected earlier, but now that I know your background and your connection to the team a little better, I'm sure we'll be consulting you. So, thank you very much.
Thank you.
All the music in this episode was written and performed by Koteskey of Two-Faced Heroes. Thanks a lot, Nick.